Hello and welcome. In this video, we're going to be going through what I think is the toughest question that ever came in 9709 M1 Cambridge A-level mathematics. And we're going to try to think about it and solve it together. And I don't think it gets any harder than this, to be honest. Okay, let's start by reading the question. So it says we have two particles, P and Q, where they have masses m and 2m kilograms respectively. The particles are held at rest initially with 6.4 meters apart. Their distance is 6.4 meters on the same line of greatest slope of a rough plane. So rough plane, I know that I have friction, inclined at an angle alpha to the horizontal where sine alpha is 0.8. So I know that by constructing my right angle triangle, this is alpha. 0.8 is basically the same as 8 over 10. So sine 8 over 10 means the opposite is 8, hypotenuse is 10. And if I quickly do square root of 10 squared minus 8 squared to get this side, is going to give me an answer of, okay, 100 minus 64 is 36. So it's going to give me an answer of 6. And here I can say that my cosine alpha is going to equal adjacent over hypotenuse 6 over 10, or basically 6 divided 2 is 3 over 5. So this is cosine alpha. Sine alpha is 0.8. This is to make my calculations easier. So let's continue. Particle P is released from rest and slides down the line of greatest slope. And simultaneously, at the same instant, particle Q is projected up the same line of greatest slope with a speed of 10 meters per second. The coefficient of friction, or mu, is 0.6. Okay, part A says that show that the acceleration of Q up the plane is this. So first of all, let me start by drawing what's happening. Okay, let's say this is the thing. I know it's steeper than this, but I want to draw it in this way to make the things more and more visible. So let's say this is our slope, this is alpha, they are 6.4 meters apart. This is Q, and this over here is P. So let's start by resolving the forces for Q. So I know Q motion is upwards. Okay, so first of all, let's start with the weight. So let's say that Q will have a component or a weight force of mg, and its m is basically 2m times g. That is the weight component, or the weight of Q. I know that this weight is divided into two components, or I can resolve into two components, because I always, when I have a line of greatest slope, I always resolve in the directions of the slope and the direction opposite to it. I no longer resolve my forces in x and y, because it makes more sense to resolve in this direction. Okay, so this component is the component perpendicular to the line of greatest slope. I will have another component over here which is parallel to the slope line. So I know that this must be alpha, because if this is 90, this is 90 minus alpha, and this whole thing here is 90, so 90 minus alpha is basically alpha. So I know that this angle over here is alpha. So this makes this component 2mg cosine alpha, and this component over here 2mg sine of alpha. What else? I will have a reaction force which is also acting in this direction. I call it RQ. Okay, and I will also have a friction force. However, in which direction? Friction always opposes the direction of motion. So if Q is projected up the slope, then the friction is going to act in this way. Let's call it FQ. And since it's moving, I know that the friction must be a maximum friction, so it's going to be equal to mu RQ. Okay, so let's start by solving A. Let's resolve in both directions for Q. Let's start by resolving in this direction and take this direction as the positive. So here I don't have any resultant force in this direction, the direction perpendicular to the slope. So it's basically in equilibrium in this direction. I don't have any resultant in this direction. So I can equate the opposite forces together. So I will have RQ should equal 2mg cosine alpha. And I know that cosine from here is basically 3 over 5. So times 3 over 5. So this is equal to 6 over 5 mg. This is RQ. Let's start by resolving in the other direction, and notice that the direction of motion is upward. However, if you roll a ball up a slope, it will move and then it will come to a point where it will stop. This stopping because the acceleration is going to be downwards. And why is the acceleration downwards? Because the only two forces acting are in this direction and in this direction. So the forces are downwards, so the resultant must be downwards, and always the acceleration is in the direction of the resultant. So I like to take the direction of the opposite, the direction of the acceleration as the positive direction. But in this case, because he wants me to see that the acceleration is in negative, and he tells me explicitly that the acceleration up the plane is negative, so I will take the opposite thing. I will say that this direction is going to be my positive direction, and I will start to resolve. I will have a minus 2mg since it acts in the opposite direction, it acts in this direction, and this is my positive, so it must have a negative sign because it's acting, as I said, in this direction. So negative 2mg sine alpha, which is 0.8. And then I have a friction force also acting in the negative direction, so it's going to have a negative sign of mu, which is 0.6 times RQ. And what is RQ? 6 over 5 mg. And this is no longer equal to 0 because I have an acceleration. So this is going to equal 2m times a. So because in the dynamics equation where I have accelerations, I will put my forces, add them together, noting the correct sign for each force, and then equate it to ma. So from here, I can find my a. First, I can cancel all the m's, and I will have minus 2 times g, which is 10 times 0.8, minus 0.6 times 6 over 5 times g, which is 10, is going to be negative 116 over 5 equals 2a, and then dividing by 2 both sides, a is going to equal negative 58 over 5, or this is the same as negative 11.6 meter per second squared. So this is part A, fairly simple and easy. Let's move to the tough part, okay, where it says find the time for which the particles are in motion before they collide. And this is very tricky because you need to think about it. We have two scenarios for where the particles collide. This particle is moving upward, this particle is moving downward. The easiest and most straightforward scenario is this is moving, so they reach both the same time and they collide. That is the first scenario. The second scenario is what? I know that this particle, which is Q, is moving upwards, however, it will stop. And when it stops, it will start rolling down back again. Okay, so it's moving upwards and then it will stop and start rolling back. So the second scenario is this P is moving downwards. Q reached its maximum distance, okay, and then it's going to start rolling down again, and then it's going to be here, Q dash, and P is going to be here, which is P dash, and then they will collide when they're both moving down the slope. And this is the second scenario and the more complex scenario, but however, we need to understand or distinguish or decide what scenario is happening here. And the only way to do this is to see how much did RQ move until it reached to rest. So what's this distance? And how much and how long did it take? Let's say what's the time did it take? And when P moved for the exact same time, where is it? Is it here or is it after? Okay, so what we should say is the distance that Q moved, okay, until it reaches 0, and the distance that P moved at that exact same time that Q took to reach to 0. If these two distances, like SP, okay, plus SQ If they're more than 6.4, that means that they will collide before Q starts sliding down. However, if they are less than 6.4, the opposite is going to happen. And let's solve to showcase that more accurately and to understand it even more. So let's start by thinking about particle Q. Okay, so let's say particle Q. I will take the direction up the slope as positive. I have my U, which is 10 meters per second from the question it was given. It's 10 meters per second up the slope, so it's positive. I have my V. I want to see when V is 0 or when Q is stationary, because this point is what I'm interested in. I know that my acceleration is in the opposite direction, 11.6, so it's negative 11.6 meter per second squared, so it's in this direction. And I want my S, how much did it move, and I want how long did it take. So first of all, to find S, I will use the equation that doesn't have a T in it. So I will use V squared equals U squared plus 2AS. So V squared is 0, 0 squared is 0, U squared is 10 squared plus 2 times acceleration, which is negative 11.6 times S. So if I move this to the other side, this is going to be negative 10 squared or negative 100 equals negative 11 11.6 times 2, which is negative 23.2 S. So from here, S is equal to 100. Divide this answer. So S is 4.31 meters. So S took 4.31 meters until it reached to a complete stop. So this distance over here is 4.31 meters. Let's see how long did it take to reach this distance, or what, after what time did it reach the maximum distance and it stopped and it will start rolling back down again. So let's basically find T. So to find T, I will use the equation that doesn't have an S in it. Okay, so I will use V equals U plus AT. So V, which is 0, equals U, which is 10, plus A, negative 11.6 times T. So basically T equals 10 over 11.6, which is going to be equal to 25 over 29 seconds. So this is the time it took for Q to reach the maximum distance it will move and stop and start rolling back again. So let's see what's happening to P after that time. After that time, when Q stopped, where is P? So let's start by doing that. So first, we need to resolve P. I know that it will have a weight of mg. This weight can be resolved into these two components. This is alpha, so this is going to be mg cosine alpha. This is mg sine alpha. I will have an rp, and now the direction of motion is downward, so the friction always opposes the direction of motion, so it's going to be this side, and it's going to be a maximum friction, so it's going to be mu rp. So now let's try to resolve P in this direction first to see what's happening. So I know that RP should equal mg cosine alpha, and I know cosine alpha is 3 over 5. So basically, this is the first equation. Let's resolve in the other direction, taking this direction as positive. Okay, so I will have an mg sine alpha, which is 0.8, and then minus a mu rp, so mu is 0.6, rp is 3 over 5 mg. This should equal m times the acceleration. So the acceleration of p is going to be 0.8 times 10 minus 0.6 times 3 over 5 times 10. So it's going to be 4.4 meter per second squared. This is the acceleration of P moving down. So now I know the acceleration of P moving down. So let's see, let's do the kinematics for P And let's see how or where is P after 25 over 29 seconds. So for P, for P, I know that U was 0 because it was moving. It was initially at rest. Let me take this direction as positive, okay? This is the direction of acceleration. So acceleration is in that direction and it's equal to 4.4. We just got that, okay? I know that time is equal to 25 over 29, and I want to know where is my particle after this time. So I will use the equation that doesn't contain a v because I didn't mention v. So this equation is basically s equals ut plus half at squared. So s equals 0 times 25 over 29 plus half times 4.4 times 25 over 29 squared. So this is going to give me a distance of 0.5 times 4.4 times 25 over 29 squared is going to give me a distance of 1.635 meters. So basically, after the same time that Q took to reach this point, P moved only 1.635 meters. So P is now, so this is Q dash, this is P dash. So this part over here is 1.635 meters. So if I combine these two, distances, the distance that Q moved and P moved, I'll have a 1.635 plus 4.31. This is going to give me a distance of 1.5. Is going to give me a distance of 5.945 meters, which is not exactly 6.4 or more than 6.4. So this means that they still have a distance between them when Q stopped and will start rolling down. So Q will start rolling down before they collide with each other. So this is the second scenario that we talked about. And this distance between them, if this whole thing is 6.4, so I will remove 5.945 from 6.4. This is going to give me the distance between them, which is going to be 0.455 meters. So this distance over here is 0.455 meters. Okay, so let me think about what's going to happen now. Let's draw the same thing again, however, with this new position that we're in. So now we know that this is Q over here, this is P, the distance between them is now 0.455 meters, and this was after 25 over 29 seconds. So let's see what's going to happen now. So if this is Q, we're going to have 2mg, we're going to have, this is alpha, this is 2mg cosine alpha, this is 2mg sine alpha, and now Q is going to roll down, and if it's rolling down, the friction force is going to act in the opposite direction. So it's no longer acting in this direction like the initially. It's now acting in this direction, and this is our Q, and my friction is going to be mu r Q. This is what's happening to particle Q over here. Let's draw P a little further so we can draw and have a nicer drawing. Okay, so this is P. I know that this is mg, this is mg cos theta, this is mg sine theta, or alpha, sorry, it's alpha, and it's the same thing. P, nothing changed for P, so I know that my acceleration for P is the same, everything for P is the same, and this is going to equal mu r P. So now let's think about what's happening. First of all, I know that Q is going to move down with a new acceleration now. P will move down with the same acceleration. So let me start by getting what is the acceleration of Q. But first, I need to know what's going to happen. I know that my two particles are going to move in this direction. and they're gonna collide over here, let's say. So Q, let's say this distance to the collision is x. So if this is the distance between the collision is x, so this distance must be, because we know that this is 0.455, this distance must be x plus 0.455 meters. So basically, we want the time where P moved this distance and Q moved x distance. This is going to give us the point where they collided. So to do so, I will need kinematics, and to know what's the acceleration for Q, I will need to get it from resolving here again. So let's start by resolving in this direction for Q. Okay, so I know that RQ will equal 2mg cosine theta, so it's the same, so it's going to be also 6 over 5 mg. And let's resolve now in this direction as positive. I know that my 2mg sine theta, which is 0.8, this is in the positive direction, minus mu r, which is 0.6, times rq, which is 6 over 5 mg. This should be equal to 2ma. So now I can cancel all the m's, and I can get my new acceleration, which is going to be 2 times 0.8 times 10 minus 0.6 times 6 over 5 times 10, and this is 2a equals 44 over 5. So a is basically that divide 2, which is going to be 4.4 meter per second squared in this direction. This is my new acceleration after the frictional force shifted. And I can see that when the frictional force is now acting opposite to my acceleration magnitude will decrease, because it was higher in the first acceleration that we got for Q. We got it as 11.6. So that's just something for you to think about. Okay, so now let's conduct the equation for Q at s equals x. So I know that my s, my distance that I want, is basically when Q moved a displacement of x in this direction. So let's say this direction is positive. I know that for Q, this is for Q, that my u is 0 because it started at rest. My a is in the same direction as 4.4 meter per second squared, and I want the time where all of this happened, because the question asks about the time when they collide. So I didn't mention v, so I will use the equation without a v. So it's s equals ut plus half at squared. So s is x equals ut is 0 plus half times a, which is 4.4 times t squared. So this is my first equation where x so x is going to equal 2.2 t squared. This is my first equation. For Q, in order to do that for Q, I will need to know what is u for Q, or the initial speed that u is in at this point of time right here. So I know that at this point of time, it's basically after 25 over 29 seconds. So I need to know what is v, the final velocity from the beginning after 25 over 29 seconds, and that is going to be my initial velocity when I'm looking at this second part of the question. So in order to find v, I will use the equation without an s, so v equals u plus at. So v equals u, which was 0 in the first part, p was released from rest, plus my acceleration for p in the beginning, which was 4.4, times t, which is 25 over 29. So my v is going to equal 3.79 meters per second. So now let's do the same for p, taking this direction as well as positive. So I know that my u is now 3.79 meter per second, because this is the speed it's going to start to move with. I know that my x, or my displacement, or how far I want p to be, is basically x plus 0.455. So I'm gonna say that s is x plus 0.455. 5. I have my A for P, which didn't change from the last time because nothing changed for P. A was 4.4 meter per second squared, and I want the time at which all of this happens. So again, I will use S equals ut plus half at squared. So my S is basically x plus 0.455 equals ut, which is 3.79 t plus half times a, which is 4.4 times t squared. I can see that everything's positive here because my displacement is also in this direction, my u is in this direction, and my a is in this direction. So everything is positive, and this is now my second equation over here. When I solve these two equations simultaneously, I will get the value of t. So let's substitute this x over here in this equation. So it's going to be 2.2 t squared plus 0.455 equals 3.79 t, and then half times 4.4 is basically 2.2 t squared. And now I have an equation with all t's where I can solve for t, and I know that this is 2.2 and this is 2.2 t squared. They can cancel, so now I know that my t is going to equal 0.455 divide 3.79, which is going to give me an answer of 0.12 seconds, and this is the time from which Q started to roll downward until they collided. So first of all, what happened was Q was moving up, okay, until it stopped. This took 25 over 29 seconds, and then Q started to roll down until it hit P over here, and this part over here took 0.12 seconds. So the total time is going to be 25 over 29 seconds, adding to that 0.12, which is going to give us an answer of 0.982 seconds. And this is the total time from start until they collide, which is the answer to part B. It's super tough, very difficult, but it's fun to look at and fun to attempt. Let's try to solve part C. So part C says that the particles coalesce on impact. So basically this is now a momentum equation or momentum question. So when they coalesce, it means that they join, so their masses join and they move with a single speed. So find the speed of the combined particle immediately after the impact. So for this, we need to use the laws of conservation of momentum. So if we try to solve part C here, we know that for two particles, I know that I should have M1 U1 plus M2 V U2, and when they combine, it's going to be M1 plus M2 times a single speed, which is V. So basically, I know M's, no problem in that. I need to know the speeds just before they collide was how much. So over here, I need to know the speed, the V of Q, and the V of P just before they collide. So I know, let's start by doing for Q, okay? So I know that for Q, it took 0.12 seconds for it to collide with P. So my time is 0.12 seconds. My U was 0. My acceleration was 4.4 meter per second squared. And I want V. So I can use the equation without an S in it, which is V equals U plus AT. So my V is going to equal U plus 4.4 times T, which is 0.12. This is going to equal 4.4 times 0.12, which is 0.528 meter per second. This is the speed of Q just before the impact. And let's try to do the same for P. For P, I can take from the beginning of the question until they collided, which this was the whole time, where time was 0.982. My U was 0, my acceleration was 4.4. This was all in this direction, it's positive, and I need my VP, which is, I don't know. So I will use the same equation. So VP is going to equal UT, U, which is 0, plus AT, 4.4 times 0.982. So my VP is going to equal 4.32 meter per second. So these are now my UQ before impact, and this is my UP before the impact. So I can use these two numbers in order to do my conservation of momentum equation, which is going to be M1 U1. So M for Q was 2M, and the speed just before the impact for Q was 0.528. Okay, however, that's if we are taking this direction as positive. Okay, no, this direction as positive. They're both moving down the slope, so this direction is positive. Then adding to that M for P, which is just M, and then times the speed just before the impact, which we calculate as 3.2. This is going to equal the joined masses, which is M plus 2M, times the speed, which is V. So from here, I can basically say that this is 2 times 0.528, which is 1.056 M plus 4.32 M equals 3V M. M plus 2M is 3M. So now I can cancel M from everywhere, and V is going to equal 1.056 plus 4.32 divided by 3, which is going to give me an answer of 1.79 meter per second, and that is the joint speed that they will both move with, and this is basically the answer to part C. It's not an easy question, it's a tough one, probably the toughest ever. It's good to attempt it, to take a look at it. What I'd encourage you is to try to re-attempt this question, okay, without the video, and see what part you feel is confusing or you didn't know how to do on your own, and then you come back to the video and see how I solved it. And please don't forget to subscribe, like, and comment. If you have any suggestions or questions, leave them down below. I will read them all. Thank you so much for watching. Don't forget to sub and watch the previous videos, and have a nice day. Thank you.